Hello, I am Chris, Center Star. Welcome back, my stars. Today we're going to talk about math concepts and the difference between solid Earth and hollow Earth and how hollow Earth works and when we look at math differently. Okay? The best way to put this is, let's say that I hand you two rocks and I can't draw them exactly the same size, but for all intents and purposes, I hand you two rocks and they look absolutely the same. And I ask you to tell me the mass, the volume, okay, and the weight of these two rocks without using anything other than basic external measuring devices, measuring the circumference and everything else, but you're not allowed to use a scale, all right? Because that's how we calculate the gravity. Everything on Earth is based off the assumption that both rocks are equal, okay? Now, when you're completely done, I take a hammer and I break, or even a saw and cut in half, rock number one. And I take a hammer, break, or cut in half, rock number two. And on rock number one, we end up with two opposing halves. And they're solid all the way through. Yeah, see, I said I can't draw perfect. And we break apart rock number two. And whammo, it is a geode, and we have a huge hole in the center. But that's information you didn't know, because you couldn't see it, you didn't observe it, and so you assumed it was rock number one, okay? And that's what we do with Earth. We can't put Earth on a scale. We can't weigh it. And when we look over here, this is what we assume, that it's solid all the way through, okay? We tell ourselves there's no way the Earth can be expanding outward, all right? Because the matter within would actually be pulling it down due to gravity. At the center, and we would need extreme amounts of heat to expand the matter and expand the Earth, okay? So expanding Earth is out of the question scientifically. I mean, there's people that say, well, maybe expanding Earth, if we're getting enough dust rain down on the Earth every year to add more mass. But they cannot see the Earth actually expanding. They have no concept of hollow Earth because the mathematics are based off the presumption it's solid. Our gravity calculation is based off it being solid. Now, if they knew, okay, or looked outside the box and understood hollow planets, they would redo the gravity calculation. And they would find that if we were actually solid and they used this calculation, we would be flat pancakes. Okay? But the fact is, with hollow Earth, the more that it expands and grows, the thinner the crust gets in the shell, okay? And even though this gravity will essentially almost stay the same because the consistencies of the center sun, okay, the center star, the people inside of it that are on the inside of the crust are held down by less gravity underfoot, and therefore they're going to get bigger and bigger and gigantic, okay? So when people ask me what's inside the hollow Earth, everything that's out here, but on a big, much grander scale, okay? Some of these concepts are used in books like Journey to the Center of Earth with the Floating Rocks, Avatar, when you have another external planet, okay, a huge planet compared to the little moon of Avatar, of that world, and you have floating mountains in between, okay, because of the gravity difference here is pulling, and we have floating mountains directly in between, okay? There are points within the hollow earth where if you were the size that you are now and you're walking, you would feel lighter in air. And we will get to that when we get to the book, The Smoky God, written by George Willis Emerson and published in 1908 following the death of Olaf Jansen. It's a biological novel, okay? And the preface is almost as big as the book itself, only explaining the life of Olaf Jansen and how real he was, okay? And I will get into a research project where my friend Stefan Sindoni looked it up. But you need to start thinking about math differently when we talk about hollow earth concepts. Because if you stick to what you've been told, sure, you can say, I'm absolutely right, okay? I'm absolutely right because I was told that the world is solid and our mathematics back that up. Well, again, have you put the earth on the scale? Have you seen the inside? Okay? The reason we can't get through here is there's magma sandwiched in the crust. And we can't dig down too deep because it gets hot. But not everywhere. There are caves where the freshwater aquifer drains through and comes out in springs inside the earth. Okay? So we'll get into more of that. If I forgot anything to tell you, I will continue that in other videos. But you have to understand that there's more than one way to look at things. And the mathematics aren't incorrect, but the input is incorrect. And when we start to understand that, we start to get a better understanding of how this is not only plausible and scientifically sound, it's a better explanation than what solid earth is altogether. I'm going to teach you that. I'm going to teach you the concepts. But I'm also going to teach you the concepts that were wrong. So starting out on our next video, we are going to be talking about Sir Edmund Halley, or Halley, however you know it, the guy that found Halley's comment and what he put in public about the hollow earth and how his was probably wrong. And that's why it got washed under the rug and is rarely talked about, even in college campuses. His idea isn't talked about, but it's verifiably checkable online to go out and look up Sir Edmund Halley and the hollow earth right now if you want to get ahead of the game and see what his concept was. But I will be teaching you about that next time. So my stars, if you could do me a solid, like this video, share it. If you're not subscribed yet, subscribe and hit the bell notification button. And as always, I look forward to seeing you next time, teaching you more. Peace.